Argument unpacking in Python allows you to flatten containers for each item to be a function argument. For example, if we print star of list 1, 2, and 3, if we run this code, you'll see it's like we printed each item individually instead of passing in a whole list. This isn't exclusive to lists. We can do print of star set with 1, 2, and 3. If we run this code, it is also like we printed each item individually. Also, you aren't limited to a single layer of unpacking. You could do print star of list star string 1, 2, 3. If you run this code, you'll see again 1 through 3 separated by a space. Last, you can use double star to unpack a dictionary into keyword arguments. You could do print star of list 1, 2, 3, comma, star star of dictionary with string sep mapped to string dash. If we run this code, you'll see 1, 2, and 3 are separated by a dash. It's as if we called print with 1 through 3 and the keyword argument sep being a dash. Extended iterable unpacking in Python adds a catch-all syntax to unpacking. For example, as you normally know unpacking, if I do A, B, and C equals range of 10, this will result in an error as you're attempting to unpack 10 values into 3 variables. With a singular star, we can fix this error. If we put a star before the B, it will change the line of code like this. Let's print A and C. Then in another print B. If we run the code, we'll see A and C are the first and last items of the list respectively. The B, however, now has everything else. That's the main way extended iterable unpacking is defined to work. The variable with the star in front of it consumes as many items as it can, leaving room for the mandatory expressions. There is a small note here though. If we do A, comma, star B, comma, C equals a tuple with 1 through 4, we know what B will hold. It will hold 2 and 3, but what is the type of the container? If we print B, we'll see it as a list. This feature simply defines that the items consumed by the star will go into a list. Last note, if we do something like star A equals range of 3, we'll get an error that the A must be in a list or a tuple. So we could do this assignment, we just have to turn it into a single element tuple by putting a comma in front of it. Today we'll talk about flattening iterables in Python. The star and star star operators in Python give you further abilities to flatten iterables outside of just function call contexts. For example, we could do a list A that holds 1 and 2. Then do A equals a list with star A, comma, star, a list with 3 and 4. If we print A, then run the code, we'll see A is just one flattened list with 1 through 4 in it. This doesn't just apply to lists. We could do B equals set of star string ABC. If we print B and run the code, you'll see a set with some arrangement of the letters A, B, and C. Double star allows you to do something similar with dictionaries. D1 equals a dictionary with string A mapped to 1. D2 equals a dictionary with string B mapped to 2. D equals curly braces star star D1, comma, star star D2. If we print D, we'll see it contains a single dictionary with A mapped to 1 and B mapped to 2. This has been Jakubication. Like and subscribe to learn more.